following your chapter 9. We're following that example one. So we have a DQN model and we'll have a Q table. And for our paper, I guess I will leave like 1 or 2 pages to explain what is the Q table, because exactly we are going to say what we can get from interpretation, that we can change our Q table or we can explain our Q table. That's my first part, is that we have a Q table, we have the DQN model. So I want to explain that. And the second part is a sharp value. Like we already showed, is that we have the sharp value for the whole model. We have 8 features, like I introduced last time. We have 8 features. So we have a sharp value for the whole model. But now, after last week's meeting, I think about that. I think the supervised learning thing, like the way I showed you, it does not work anymore. Because for reinforcement learning, you have the result, but you cannot improve the thing by your result because you don't know what's happening in the reinforcement learning. There's no real loss function or some really good thing to check. We discussed that last time, right? I think we're in the same page. So supervised learning.
That's what that was the discussion last time. And can you hear me well? Because I'm not.
I can hear you well. Yes, great.
Perfect. Because I might not be able to connect to the video, but yeah, I mean, I got your point.
Yeah.
Yeah, you can continue. Yep.
Okay. So like last time, we say something about the supervised learning, but unfortunately, actually for reinforcement learning, there's not a good way to check if this change will improve the model or will make the model worse. So that's the bad thing about the reinforcement learning. And in that cases, my guess or my attempt on the following months or following weeks will be, how about we do the sharp value for different cases? That's my guesses at this moment. So can we do the sharp value for the days we buy the stock, and we analyze the sharp value for the days we sell the stock? So they will have different sharp value, because for the buy days, maybe the volume matters. And for the sell days, maybe the market matters. So we want to do a sharp value for that. Then we can also give you some interpretation. Does that make any sense?
Yeah, that makes more sense as compared to what we discussed last time.
Yes, yes.
And you can always go for, but so what's the improvement on top of the grid that we had last time? So if you remember the previous project, there was this grid that we had. On x-axis there was this volume, y-axis there was this change in spot, and we had this kind of heat map which showed that in what kind of movement of volume or the price, whether the algorithm is buying, selling, or holding, right?
Yes.
So the shock thing that you mentioned, how it is adding value on top of what we had before in terms of the heat map?
I guess the main thing is that the sharp thing will give you the attributions in a different way. Because what we have before, the Q table, is kind of like a linear regression. We have the weight in front of the parameters. So it's like we know volume will have this kind of effect. But sharp value from the very beginning, it have a different meaning, right? The sharp value means the attribution, which means if we take this part out of our prediction, what will be the prediction? Yeah, that's different. That's not like a weight thing. It's not like
so you are just so when you are shocking, what are the values of the shocking the shocks that you're applying? So you said that you're taking out the variable. So is that one of the shock scenario?
Yeah, the sharp value, I can give you a kind of a really succinct definition. Sharp value says we have A, B, C, 3 guys working on a project. Sharp value says if 3 guys work on a project, what's the outcome? Then we take A out of this project. What's the outcome? B and C.
You're referring to, got it. I thought you're saying shocked value. So sharp value, yes, I understand. I mean, that's the attribution of one particular variable to the overall result. So on what parameter you are applying the sharp value?
Oh, you mean SHARP as a sharp value? The sharp ratio? I'm sorry.
I thought you're saying SHAP.
Yes, that's I'm saying yes. Shock
Okay.
value.
So earlier I thought it's shock, SHOCK. So that's where I got confused.
Oh.
So
Okay.
yeah, I mean, SHAP I understand. So it's the attribution of each of the variable. But the thing is, I guess this is something we discussed before. On which variable you will be applying the SHAP
Oh, yeah.
attribution?
Last time I mentioned that we are going to, because I'm going to analyze a specific stock. So the total market, like the Standard Poor's, like the Nasdaq index, those things could be your new features because there
Right,
are
right. I mean, feature wise, I'm fine. So let's say you have like 8 features,
yeah
and 8 features are contributing to
yeah
20% of the profit,
yeah
or
okay
let's say profit of $20.
okay.
So when you're applying the Sharpe value, are you applying on the profit or something else? That's
Oh yes, now we'll apply the sharp value on the profit. Yes.
yes. So I guess this is a point. This is a point we discussed before. If you're applying the Sharpe value to the profit, I'm not sure how meaningful it would be, uh, because you are training the model, and after the model is trained, you are, let's say, running it. The profit is $100,
Yeah.
and just for that particular uh, test run, you
Yeah.
will be applying the Sharpe value. So
Yeah.
let's say the total number of variables are 10, your total profit of 100. Each one gives you $10.
Okay. Okay.
Then how do you interpret it? I mean, this is just one case, right? So how do you generalize it from this one, just one case, that what's the attribution or what's the interpretability of each of the variables? Getting what I'm saying?
Yes. Now I get what you're saying. So, it's like we don't have one of the feature, but we earn more money. Does that say that we don't need that feature to earn more money? Yeah. That's a question because it's not really like A, B, C cooperate in a project. Like A will give you some contribution, B and it's different.
Right.
Yes.
No, I agree. It's a good idea, but the only thing is you might have to run it on different test cases, right? So just one scenario running on one of the case, the example that I gave, $100, $10 attributed to each.
Yeah.
That's, if you are drawing the interpretability or interpretation from that, that's just one case,
Yes.
right? When you vary the time period, when you vary the, let's say, stock, or very different test cases, then let's say you take the average of 100 runs, then it will give you a proper understanding of what's the interpretability. Do you get what I'm saying?
I'm a little bit confused. So you say we have 10 features and we have $100. So for one stock, then we change the stock and we change the time frame. Is that?
Yeah. So let's say you get a profit of $100,
Yeah.
right? That's just one run. That's just one case.
Yeah.
Yeah. And if you're saying that each of the feature is contributing to $10,
Yes.
from one run, that might not be the right conclusion, right? So you need
Yes.
more number of runs, a more number of test case, and then do some kind of averaging from all these runs. And then you can conclude that, yes, this is the most important variable, or this is the second most important variable. From just one test run, I'm not sure whether the conclusion will be solid. That's my point.
Okay. So we run multiple cases, maybe multiple stock, maybe multiple time frame. Then we
Exactly.
do an average. Then we find the sharp value, which is more reliable. Then we do it
Yes.
once.
That's what I'm. Yep.
Good. Thank you. I got it. Yeah.
Yeah.
Okay. Thank you so much. Yeah.
Yeah. Some from just one run, there might be quite a lot of noise. So you might
Yes.
have to make sure that it's reliable by running more number of cases, by varying stocks, or by varying, let's say, the time period, or maybe generating some dummy data or simulated data. Right? You can do Monte Carlo simulation and run it, and then check the output on, like, that. Take the average of all the Monte Carlo runs, and then maybe get the interpretability as an average.
So the most important thing, most important philosophy behind this model is averaging idea, right? It's like
Yeah, I guess so. Yep. averaging.
Okay.
Better because,
That makes sense. Yes.
right. You have to just make sure that the output that you're getting is reliable, not
Yes.
from just one run.
Yes. Of course, we cannot say this is one stock. Then this one stock will give you exactly the really important feature. Yeah, that's not.
Yes.
Okay. Thank you so much, Harry.
Yeah.
Okay.
But good stuff. Yeah.
So that's
I
the
like
idea
that.
for, so we're pushing towards that publication around that. Okay. Project number 10. So Shitali and Karen.
Yeah, Chitali, you want to go ahead and take this one because I think
Yeah,
you have
I
a
will,
lot
I
of questions.
Yeah, so hi Harib. So I